Hi and welcome to the Mathemagic channel. Today we look at how we can solve 8 to the power x plus 2 to the power x equal 130. Hard equation, but manageable. Let's go. Alright, so the first step here is to think about the fact that 8 is a power of 2. And what we can do here is change 8 into 2 to the power 3. And this is going to be 2 to the power x plus 2 to the power x and say that this is equal to 130. The next step here is to realize that when you have something to the power, they get multiplied. So we can say that this is 2 to the power 3x plus 2 to the power x, and this is equal to 130. There is a technique in mathematics called a change of variable, and I would suggest here that you do exactly that. Call y 2 to the power x and rewrite the whole expression. Now, if y is 2 to the power x, we're left with y cubed plus y, and that is equal to 130. Solving a cubic equation is not straightforward. Usually we can solve quadratic equations. There is a general formula for cubics, but it's not commonly used. So the way that we should solve cubic equations is to find a solution first and perhaps do something like a long division to simplify this problem. Looking at this cubic equation, we can try and plug in some values and see if one of the values might be a solution. You can try with 1 cubed plus 1 and realize that that's 2. You could try with 2 cubed plus 2. 2 cubed is 8. 8 plus 2 is 10. You could try with 3 cubed plus 3, and that'll be 27 plus 3, which is 30. And so on until you get to a pretty nice solution, which is 5 cubed plus 5. And 5 cubed is 125. 125 plus 5 is 130. And so we know here that 5 is a solution for this equation. So with the knowledge that 5 cubed plus 5 equal 130, we can actually divide our expression by y minus 5, and we should have no remainder. So this is a divisor of our expression. Using that fact, we can rearrange the expression as y cubed plus y minus 130 equals 0, and look to do what is called a long division or polynomial division. So I'll put this expression on the side here, y cubed plus y minus 130 equals 0, and we're going to try and solve this cubic. Now let's remember that cubic equations must have 3 solutions in the real or in the complex numbers, so let's see what we find out. Setting up our long division here, we're going to write y cubed plus 0y squared plus y minus 130. And the purpose of doing that is to make sure that we don't make a mistake when we come to subtracting for the y squared terms. I would really encourage you to make sure that you have every single power of x written out when you're doing a polynomial division. And we're going to divide this polynomial by y minus 5. And you can handle this exactly the same way as you would if you were to do a long division. So how many times does y fit into y cubed? You can say it fits y squared times. Y squared times y is going to be y cubed, and y squared times negative 5 is negative 5y squared. And now you can see the point of writing the 0y squared so that we don't make a mistake when we're subtracting the negative 5y squared from the 0y squared. You should do the first line minus the second line here for polynomial division. Y cubed minus y cubed goes away. 0y squared minus 5y squared is plus 5y squared, so we're left with this one. And then we can drop the y down, so we'll drop the positive y down. And repeating this process, how many times does y fit into 5y squared? Well, it will go 5y times. So we're going to say 5y, and again, 5y times y is 5y squared, and 5y times negative 5 is negative 25y's. And so we subtract the first line from the second line. 5y squared minus 5y squared goes away, so we have a 0. And y minus 25y is positive 26y. And from this point, we need to drop the 130 down. And if we're correct in saying that 5 is a factor of the equation, we should have no remainder here. So how many times does y fit into 26y's? Well, it fits exactly 26 times. And so we can say 26y here. And what is 26 times negative 5? Luckily for us, that is negative 130, so that when we do this division, we're left with a 0. So the result of this division is a quadratic, and the quadratic is y squared plus 5y plus 26. The next step in our problem here is to solve this quadratic, y squared plus 5y plus 26 equals 0. Can we find factors of 26 which add up to positive 5? So perhaps 13 and 2, 2 times 13, 2 plus 13 is equal to 15. That's not very good. And so it doesn't look like we have two positive factors which easily add up to positive 5 here. So we're going to use the quadratic formula when the solution is not obvious, and we'll say that the delta value is equal to b squared minus 4ac. In this case, the b value is 5, the c value is 26, and the a value is 1. So we can say that b squared is equal to 5 squared minus 4 times the a value, which is 1, times the 26. And so we're going to be left here with 25 minus 4 times 26. Now 4 times 25 is 100, so 4 times 26 is going to be 100 plus 4, so minus 104. 25 minus 104 is going to be negative 79, and that is a negative value. Therefore, we have no solutions in the real numbers. So no solutions in the real numbers. Now, not to worry, when we have no solutions in the real numbers, we can look for solutions in the complex numbers. So I'm going to write our delta value here, which is negative 79. And to find our solutions in the complex numbers, we can say that delta is equal to 79i squared, knowing that I squared is equal to negative 1. So this will lead to the square root of delta becoming square root of 79 times I, and this leads to solutions in the complex numbers. So we can say that the first solution is going to be minus b, so minus 5, minus the square root of 79 times I over 2. And the second solution is going to be minus 5 plus the square root of 79 times I over 2. This is just using the quadratic formula with the delta value being the square root of 79i. And so we can say that this is for y1 and y2. So we do have a solution set here with two solutions. So writing our solutions on the side, y1 is minus 5 minus the square root of 79i, and y2 is equal to minus 5 plus the square root of 79i. So to finish this question here, we're going to say that 2 to the power x is either equal to 5 or 2 to the x, and I'm going to group those together, is equal to minus 5 plus or minus the square root of 79i over 2. The issue with 2 to the power x being equal to a complex number is that 2 to the power x is expressed in the real numbers, it's just the power of 2, and there's no imaginary part to it, and it's not really possible to make the exponent imaginary to change a real number into an imaginary one. So we're going to say that this real number value is not actually equal to an imaginary value. And so just based on that fact, we're going to reject this solution and probably investigate this one and think that this is the only solution to this problem. To finish the question, we can look at base 2 and say log in base 2 of 2 to the x equal log in base 2 of 5. And so this leads to x equal log in base 2 of 5, which we can plug into a calculator. Plugging this into a calculator on rapidtables.com, log in base 2 of 5 is equal to 2.3219. We can simplify that and just say that it's equal to 2.32 approximately. So our final answer is going to be x equal 2.32, and this will be rounded to 2 decimal points. So just to make sure that we're not wrong, we're going to stick that into Desmos and see if Desmos agrees with us. So if we look at this curve on Desmos, we notice that of course the values are very, very big for a small x and y axis, but there is very clearly a point of intersection, which we can call a solution to this equation. And if we go click on it here, hopefully it's correct. And we see indeed that 2.32 is a solution to this equation, and it looks to be the only solution. So I guess we got the question right, and we're pretty happy with the way that we got around to it. Thank you for doing this Math Olympiad question, and please continue to like and subscribe to the Mathemagic channel for more math content. See you on the next one. Bye-bye.